We hear about the moon in songs. There are love stories about kissing in the moonlight. There are poems about the beauty of the moon. There are myths about the man in the moon. And there are legends that have been passed down for generations to generation about the power that the moon holds. We see the moon every single day. So what is some of the science behind the moon that can help us to understand it better? We all play scientists in our daily lives by working every day to understand our surroundings better. Today, let's harness that scientific questioning and inquiring on the moon. I'm going to share some claims about the moon and guide you through each of the questions that led me to each of these claims, as well as how I answered those questions. The 3 claims that we'll be looking at today is number 1, the moon rotates a little each day. This causes us to see different phases of the moon. One complete moon cycle around the Earth, it takes about 29 and a half days. Number 2, we can view the part of the moon that faces the Earth with a telescope, but the far side can only be seen from space. And finally, number 3, the distance between the Earth and the moon is 384,000 kilometers. A scaled model can help to show us what that looks like. Let's focus on claim 1. So the moon rotates a little each day. This causes us to see different phases of the moon. One complete moon cycle takes around 29 and a half days for the moon to go all the way around the Earth. So take a look. This is from just a couple months ago, what the moon looked like on each day of the month in February 2015. So you can kind of see that it does go through a cycle. It starts one way. You see it disappear basically at a new moon around the 18th of the month, and then by the end of the month it's back to becoming a full moon again. So one of the questions that got me to come up with this claim was, how does the moon change day by day? When we look out every day, what are the different things that we see? So I know that we looked at that calendar and we saw that the moon looks different every day. So I did some research on what causes that. So I found out that it's because the moon is circling around the Earth. But I thought, well, the Earth is rotating, the moon is circling it. All of this just seems too much to me. So I thought, how can I picture this so that it makes more sense to me? So this is a good representation. So the Earth is revolving around the sun like this, and while that's happening, the Earth is rotating in this direction. And meanwhile, the moon is moving counterclockwise around the Earth. So I really like this picture. It helps me to kind of gather those thoughts and think about, okay, this is not overwhelming. I can see that there's different processes happening, and that the moon is moving counterclockwise around the Earth, and that is why I see what I see when I look out every day. Part of it. We'll find out more about the why here soon. And leading right into that, why do we see different phases when we look in the sky? So I like this representation. And come around so you can see the sun here, and the Earth is here, and then depending on where the moon is in relation to those two objects, that's going to be how you see different parts of the moon. So the sun is lighting up the moon here. This side of the moon, the side that we see from Earth, is completely dark. It's a new moon. Here at the full moon, the sun is completely shining on the moon, the side that we see, so it's a full moon. We see the whole thing. Now, in these areas, it's kind of at an angle. You see, the sun isn't, or the moon is not directly between the sun and the Earth. It's not, directly here. It's more of at an angle. So we see those different phases as we see parts of the lighted portion of the moon. So one thing that I've always heard is that the moon doesn't light up and that the light we see is a reflection of the sun. Kind of hit on that in the last slide. What does the sun have to do with the phases of the moon? So as you can see, these moons right here are the part of the white part is the part that's lit up by the sun, and the dark side is the part that is not lit by the sun. Now, it is always like that. No matter what time of the day, 50% of the sun or 50% of the moon is always lit by the sun, 50% left in the dark. So these moons out here are what we see as a representation when we look at the moon from Earth. So, right here we see full sunlight. Here we see, the sun is on this side of the moon. So from Earth, we don't see anything at all. When this side of the moon is lit, here's Earth, we see the lit part. Okay, so now we are going to go to claim number 2. And claim number 2 says we can view the part of the moon that faces the Earth with a telescope, but the far side can only be seen from space. So, let's talk about what can we see. Okay, so the question that kind of got me to that we can only see the half that we can see is, well, what can we see in the first place? And what we can see is basically what we can see with our eyeballs and what we can see with a telescope. Those are really the 2 ways we have of seeing the moon. When we look through a telescope, actually, let's start. When we look with our eyes, we see that the moon has some features. They're not this defined, but we see, some people call it the man in the moon. You see some darker and lighter features on there, but this actually shows you that there are craters, there are, all these different areas on the moon, and they actually have names. They are real areas on our moon, and they stay in the exact spot all the time. And when we look with our eyes, this is what we see. So I think this picture is a really good representation of how you see those things on the moon that we can see in more definition with a telescope. Now here is an image where we see a less defined image of the moon. And here is a really good representation of a different moon phase. And you can see here that this is, this part is not lit, but that the entire moon is there, but this part, it just isn't lit up. This part is lit by the sun, and it's the part that we can see at that time. Okay, so how do we know what the far side of the moon looks like? We said we can only see it with a telescope, and that far side never faces us. So how we know is from looking at satellite images and things in space, we're able to see the far side of the moon. And I think that it is so interesting. Look at the differences between the near side and the far side. Near side, far side. They are so different. I just think that's so wild. Very, very neat to me. Okay, now we're going to move on to claim number 3. And the third claim that I made is that the distance between the Earth and the Moon is 384,000 kilometers. And a scaled model of this can help us to understand what that looks like. 384,000 kilometers means nothing to me. I need something that says, okay, it's kind of like this, which is what scale does for us. Scale gives us a representation of what something would look like if we could comprehend just how big or just how small it is. In this case, we'll be looking at a small representation of something that is very, very large. Okay, so the question that got me to thinking about this is, okay, so I realize that I can't imagine how far the sun and the moon are apart. What does a scaled, moon-Earth model look like? What can I come up with that would be similar to that? So what I found out is that you can fit 5 of the United States on the moon, or you could fit 1 Africa and 1 Australia. So I thought, I found an idea online actually about using a globe and using tissue paper to trace those countries and then put them onto a ball that's that exact size. And that would show you how big the Earth is and how big the moon is in representation to each other on an accurately scaled model. So as you can see, I did exactly that. I thought about doing 5 of the United States, but they don't match up together as well as Africa and Australia do. I thought it was a better example and a little less cutting. So then I thought, okay, so this is how big they are in comparison to each other, but man, I still don't understand how far away the moon is. So what I did, and this angle makes it look kind of further, I think the angle I took the picture, but you can see that it is very far. So I thought, okay, I have this ball and I have this globe and I know that they're this is how big the Earth is, this is how big the moon is. But how far apart are these? So these are some images to help show how far it is. So next, here's another representation of what this could look like. So this is the Earth, and this is the moon here. And this is a scaled model of about 384,000 kilometers, a little more. And this is the size. So you have the Earth here and the moon here. So now we've seen a couple representations so we can get an idea in our minds. Okay, this is how big the moon is, this is how big the Earth is, and this is how far apart they are from each other. Now, a comparison of how that kind of works. If the Earth were hollow, 50 moons could fit inside of it. So, and when you put them right next up to each other, just like in this image, this is what it would look like. Our Earth is so big, our moon is so big, this is all just so fascinating to me. Okay, and so we talked about the distance between the Earth and the moon being approximately 384,000 kilometers, but how long does it take us to go to the moon? It takes astronauts in a spaceship 3 days to go from the Earth to the moon, and the same from the moon back to Earth. And this image actually was taken from the moon, and it is a picture of our Earth. This is one of my favorite pictures ever.